Today I will present the paper titled Predicting the Trends of Stock Price by CNN-BiLSTM-AM and Fuzzy Twin Support Vector Machine from Social Networks in IEEE CSCI 2022. This is my outline. First, I will give a brief overview of previous works. Second, I will introduce the proposed algorithm. Finally, I will report the experiment results and give my conclusion. The financial market occupies an important position in modern society, and no one can be independent of the financial market. Being able to successfully predict the price trend of financial products, such as stocks, bonds, and financial derivatives, can avoid the harmful influence of the upcoming financial crisis on real life. Many textual data sources, such as financial news, social networks tweets, and annual financial reports, can be analyzed to uncover important information for predicting the trend of stock market. In addition, the content of tweets and posts on social media is also an important source of data for stock price forecasting. Researches show that most of the content on social media is related to breaking news. In addition, social media can spread information more rapidly while ensuring high coverage of important information contained in trending news. From this point of view, social media tweets are a good source for predicting stock market. Through community tweets, we can get all the major news events that happened during the trading day, and from community tweets, we can get people's sentiments and comments on the events of interest. Deep learning has excellent feature learning ability. Support vector machine has excellent generalization ability. This research will combine the advantages of both models. This research will use a deep learning model to extract key features, and then feed the features to a support vector machine to learn a predictive model. In addition, since a simple deep learning model cannot effectively analyze the complex and heterogeneous stock price related data, this study will propose a CNN-BiLSTM-AM hybrid model to extract features, which consists of a convolutional neural network, CNN, bidirectional long short-term memory, BiLSTM, and attention mechanism, AM. The features captured by these deep models will be fed to a fuzzy twin support vector machine to build a prediction model. Fuzzy theory is very suitable for dealing with stock price prediction problems. There is a fuzzy boundary between rising and falling categories of the stock closing price. Long short-term memory, LSTM, networks have been shown to be very useful tools for learning and predicting temporal data with long-term dependencies. Yan et al. Used LSTM deep neural networks for Shanghai financial transaction data for modeling and forecasting. They use the stock price of the first 30 days to predict the ups and downs trends after 3 days. Convolutional neural network, CNN, has brought a major breakthrough in the field of image recognition. It can mine location-independent features in images. Many researchers have devoted stock trends prediction model by using CNN to analyze financial data, where the stock market data is converted into images. Maroccan et al. Used 15 different periods, 6 to 21 days, to calculate the values of 15 different technical indicators, and the resulting 15 by 15 numerical matrix can be used to build a 15 by 15 image. The 2D images obtained by these technical indicators are fed into the CNN model to predict the stock price trend of the next day. The above research literature shows that since CNN and LSTM are particularly suitable for processing time series data, they are the most commonly used learning models for stock price prediction. In addition, AM can pay more attention to more important factors and improve the prediction performance. Therefore, this study will use CNN, BiLSTM, and AM to process the time series data in the stock price prediction problem, and feed the features learned by the hybrid deep model to the SVM to construct the best stock price prediction model. Because the information affecting stock prices is heterogeneous and complex, it is difficult to predict the stock market behavior through simple models. In order to predict the stock price more accurately, this study proposes a method based on CNN-BiLSTM-AM and fuzzy twin support vector machine to predict the trend of stock closing price of the next day. The deep model used in this study to extract key features is composed of convolutional neural networks, bidirectional long short-term memory and attention mechanism. CNN can extract features from input stock data. BiLSTM can fully discover the interdependencies of stock time series data. AM can perform weighted calculation on different time state features, thereby improving the accuracy of prediction. The detailed process is shown in the above figure. Since the introduction of CNNs to analyze financial data, many researchers have focused on predicting stock trends by converting stock market data into images. In this study, we create the image using an approach based on technical analysis. Technical indicators are the main tools for traders to use for technical analysis. In this study, we use 15 technical indicators whose values are generated at 15 different time intervals. We use Java Technical Analysis function library to calculate the values of the above indicators at 15 different time intervals. Then we create an image of size 15 by 15, where the rows represent technical indicators and the columns represent different time intervals. An example of the image produced by this process is shown in Figure 3. Then, we feed this image to the CNN network for analysis, learn the characteristics of daily stock price technical indicators, and feed the vector output by the last layer of CNN to the BiLSTM model to analyze long-term causal relationships. In this study, inspired by the research of Kim in 2014, we use word embedding vector and convolutional neural network to build text analysis model. The CNN network that analyzes tweets and posts on financial forums in this study consists of a data input layer, a convolutional layer, a max pooling layer, and a fully connected layer. First, we aggregated the daily published forum posts as a single article. After that, this study uses the WORD2VEC tool to generate 64-dimensional word embedding vector. In the input layer of CNN, given an article that is composed of n words, and k is the dimension of the word embedding vector. This article can be expressed as a 2D matrix of size n by k formed by concatenating the vectors of these words. Next, we take this 2D matrix as an image and input it to the CNN network. Although LSTMs can capture long-range feature information dependencies, a major disadvantage of traditional LSTMs is that they only use previous states to determine future states, and do not use reverse information. However, in the application of time series forecasting, considering both the forward and backward information of time series data can effectively improve the forecasting accuracy. Therefore, this paper used BiLSTM to capture the long-term dependency. BiLSTM is composed of two LSTMs, one is from the past to the future, and the other is from the future to the past. As shown in Figure 5, BiLSTM consists of forward calculation and backward calculation. The arrows in the horizontal direction in Figure 5 represent the bidirectional flow of time series information in the model, and the arrows in the vertical direction represent the two-way flow of time series information in the model. AM selects key information from a large number of information by calculating the probability distribution of attention, and optimizes traditional models by highlighting key input data. The main idea of AM comes from the process of human visual attention. When we observe external things, we usually only focus on a certain part of it first, and everyone's focus is different. For example, when we observe a person, the first thing we might notice is his face, height, body type, clothes, etc. Once you have the information in each part, you can arrange and combine them to get the overall feeling of the person. In other words, human vision can quickly find key areas and add focus to the key areas to get the detailed information needed. Similarly, AM selectively focuses on some more important information, ignores less important information, and assigns the importance of the information. In this study, we use fuzzy twin SVM as the top layer classifier to predict the trend of stock market. Fuzzy twin support vector machine integrates fuzzy set theory into twin support vector machine and perfectly combines the advantages of support vector machine and fuzzy theory. To estimate a pair of optimal fuzzy surfaces, we solve the following optimization problem. Each training sample is assigned a fuzzy attribution degree, which represents the strength of the training sample belonging to the corresponding category. For more uncertain sample points, e.g., noise, a lower degree of fuzzy attribution is assigned to avoid overfitting those noise points and increase the generalization ability. The fuzzy decision function of fuzzy twin SVM is defined as follows. The return value of this fuzzy decision function is bounded between 0 and 1, which represents the fuzzy attribution degree of the sample point belonging to the positive category. There is a fuzzy boundary between the positive and negative categories, and this fuzzy boundary is better able to deal with the imprecise and fuzzy characteristics of reality. It is worth noting that the fuzzy decision function also provides the degree of confidence in the prediction result. The larger the return value of f, x, the stronger the possibility that belongs to the positive category, and the degree of confidence in the prediction result is also bigger. For decision-making tasks, being able to provide a level of confidence in the predicted outcome is an important advantage. This study attempts to predict the stock price trends of Taiwanese companies through word mining and machine learning techniques. Users tend to actively discuss the stocks of companies with large stock market trading volume. Therefore, this paper is aimed at stocks with high stock market trading volume, Taiwan Semiconductor Manufacturing Corporation and Optronics Corporation. We collect tweets and posts from the discussion areas of TSMC and AUO on the Mobile 01. The data collection time is from January 2019 to January 2020. All tweets and posts of a trading day are merged into a daily user community tweet corpus. The task of predicting the trend of stock price changes is a fuzzy classification problem. For a stock sample whose stock price has risen plus 3%, its membership in the up category is higher than the membership with a 0.03% increase in the stock price. For a stock sample whose stock price has risen 0.0001%, it is located at a fuzzy gray area between the up and down categories. In this paper, we apply the following S-membership function to assign fuzzy membership to each data sample. The greater the stock price volatility, the greater the membership in the ascending, or descending, category, and those data samples play more important role in the classifier training phase. Conversely, the smaller the stock price volatility, the lower membership in the rising, or falling, category. In this case, these data samples are prone to noise. Therefore, the prediction errors of these data samples can be appropriately ignored during the classifier training phase. In the experiment, we compare the predictive performance of our proposed method with the following state-of-the-art stock price change classification model, including Day and Lee's approach, Pinheiro and Drazay approach, Yoon et al. Approach, Chong et al. Approach, Fisher and Krause's approach, Maroccan et al. Approach, Howe et al. Approach. As shown in Table 1, the model proposed in this paper performs better than other state-of-the-art stock price prediction models in terms of the accuracy rate, indicating the effectiveness of the stock price fluctuation prediction model proposed in this paper. Experimental results show that due to the complexity of stock price data, the method that only uses a single machine learning model is difficult to obtain satisfactory prediction results. On the contrary, the proposed model mixes CNN-BiLSTM-AM and fuzzy twin SVM, in which CNN can extract the time invariance features in stock price data, BiLSTM can explore the precursors of these time invariant features. In addition, AM can focus on important features, and finally, fuzzy twin SVM has both excellent inference ability and ability to deal with noisy data. Therefore, the hybrid model proposed in this study can achieve better performance. Here is my conclusion: the task of mining the rich public sentiment data in social networks has attracted attention of academic research. Tweets and posts in social networks have become a popular source for predicting the rise and fall of stock prices on the next day. The purpose of this paper is to use the content of users' posts in Taiwanese social networking sites to predict the changes in the stock prices of TSMC and AUO on the next day. The experimental results verify the ability of social networking site content to predict the rise and fall of the Taiwan stock market. In social networking sites, many users will use a large number of Internet terms or emoticons symbols, and these Internet terms and emoticons symbols do not have corresponding word embedding vectors, which will limit the CNN network model of this study to analyze text information, which in turn affects the prediction ability of stock price fluctuations. In the future, we intend to develop a system for learning the word embedding vector of Internet terms and emoticon symbols, so that the classification accuracy of stock price fluctuations can be further improved. Thank you for your attention.